Alright guys, so in this last section of chapter 5, we're going to be talking about factoring linear expressions. So first thing we want to talk about is finding the GCF of each pair of monomials. So we have a 4x and a 12x. Now we know that our GCF of 4 and 12 is 4 because 4 is the largest number that will divide into both 4 and 12. The new part here is dealing with our variables. So you see we have an x in each monomial, which means that we can take an x out in our GCF. Versus if we look at part B, we have 18a and 20ab. So our 18 and 20, the largest number that divides into both 18 and 20 is 2. Now if we take a look at our variables, I see I have an a and an a, so I know I can divide out an a. Now the second monomial has a b, however my first monomial does not, therefore I cannot put a b as part of my GCF. So my GCF for 18a and 20ab is just 2a. So the new part here is dealing with your variables. You want to divide out as many variables as you can, but the variable must be a part of each one of the monomials. Okay, so now that we know how to find our GCF of monomials, we're going to use the distributive property and work backward strategy to express an algebraic expression as a product of its factors. An algebraic expression is in factored form when it is expressed as a product of its factors. So basically, what that means is we're going to find our GCF. So if I have 3x plus 9, my GCF of 3x and 9 would be 3. So then I want to think about dividing. If I did 3x divided by 3, we'd be left with just x plus 9 divided by 3 is 3. So if you thought about your distributive property, we'd take 3 times x and 3 times 3, which would take us back to 3x plus 9. So that's that work backward strategy that we see up above. All right, if you take a look at 12x plus 7, my GCF of 12 and 7 is 1. And then I have an x here, but I don't have an x here, so I actually can't factor anything other than 1. So we would write cannot be factored. Now this isn't going to happen often, but it is possible that we will give you an example that cannot be factored. So again, it cannot be factored if the GCF is 1. All right, just one more problem to do together. The garden at the right has a total area of 15x plus 18 square feet. Find possible dimensions of the garden. Okay, so if I have 15x plus 18, our possible dimensions, this would be our factored form, because we know we find the area of a rectangle here by taking length times width. So another way that we could think about this, I know you guys did that tic-tac-toe board in the past, so we're going to do that real quick. So if I have 15x plus 18, I want to think about what can I divide into 15x and 18. Well, this has an x, this doesn't have an x, so I know I cannot factor out an x. If we look at 15 and 18, I can factor out a 3. So 15x divided by 3 leaves me with 5x. 18 divided by 3 leaves me with 6. If I bring my plus down, this is now my factored form. All I have to do, my line is a little too long here, is put this in parentheses. So we would write 3 times 5x plus 6. And there's our factored form. So our possible dimensions would be 3 and 5x plus 6 since we don't know what our x value is. All right, guys, that's the end of this lesson. So now you have a couple now you try problems. Number 1 and 2, you're factoring each expression, so that's that second part of the lesson. Then 3 and 4, you're finding the GCF, which was the first part of the lesson. So if you want to start with 3 and 4 and then do 1 and 2, just make sure you get all 4 of them done. All right, nice short end of the chapter here for you guys.